Okay, we're going to go ahead and start. Hello and welcome to Financial Functions in Alteryx. My name is April Pratt and I'm a Solutions Engineer at Alteryx. So for today, we're going to review some upcoming trainings available to you through our virtual trainings. Then we'll have a background on some of the workflows we're going to create today and actually open up Alteryx Designer and build out these workflows. So I believe you were sent some resources prior to the training. If you want to go ahead and download them, you can. Or if you want to just go ahead and follow along and just view what I'm doing on my end, that's okay too. We'll also review some support available to you at the very end of the presentation. And I just want to note, everyone is on mute just for the purposes of the WebEx. However, if you do have any questions, my counterpart, Joe Miller, is on the line, and he'll actually be manning the Q&A chat box in the WebEx. So again, there's a Q&A chat box in the WebEx where you can start to type your questions in, and we're going to try to answer them through that chat box. However, if we see any questions that we think are better reviewed verbally, we'll also go over those at the end of the presentation. So for upcoming virtual trainings, so these happen at 10 a.m. Pacific time every Tuesday. So as you can see, they kind of vary from the beginners to intermediate to the more advanced. So in September, we have some parsing and macro development training. In October, we have the gallery, tips and tricks, spatial, and then introduction to our Dun & Bradstreet Alteryx package. And where you can find these trainings is at www.alteryx.com/virtual-training. And this is where you can sign up for those upcoming trainings, or if you want to watch a past training, you can also do that via that link. Again, it's www.alteryx.com/virtual-training. And also want to make note of our Alteryx community. So if you're not already on the community, this is going to be a great resource for you. So this is where you can find answers quickly. So this is where you can post up your workflows or any error messages, or search for other users who have experienced these messages and start to get your answers. You'll also be connecting with other Alteryx users, and you'll have a direct connection to our product team. So this is where you can post any ideas that you might have to improve our Alteryx products and get rewards for your contributions. So these kind of colorful badges here, this is what you get as a reward for contributing on our community. And it's also great, it's a great way to share your knowledge with other users and really read insightful blog posts. So we have a lot of content on there that really goes in depth with some of the features available in Alteryx. So really an all-around great resource. And we have the link here at community.alteryx.com, but you can also get to it from our Alteryx homepage. So some background for today's training. So we're reviewing financial functions today in Alteryx. And so we're not going to exhaust the list of the available financial functions. Really, we're going to focus on the ones highlighted in green today. And all of these financial functions are going to be available in our formula tool. So for today's use case, we're actually going to go over a few different types of use cases, such as determining the compound annual gross return for a project, or deciding which investment proves to be more profitable between two options. And through these use cases, our goal is really just to understand first these financial functions, how to use them in Alteryx, and then also once you've used them, how can we use the results to make better business decisions. So that's really going to be our focus for today. So now we're going to go into our designer training, and let me just go ahead and review some of the terms that we're going to go over today. So the first term we're going to go over is the compound annual growth rate. And this is going to be the mean annual growth rate of an investment over a period of time. And so this formula really takes three arguments. It takes first the ending value of your investment, the beginning value, and then also the time frame of the investment. And the result is going to just be a mean rate. So it's not a true return rate. Essentially, it's a rate that the investment would have grown if it was grown at a steady rate. So that's just something you want to note. Okay, so this is going to be the first formula that we go over. So I'm going to go ahead and open up my Alteryx Designer, which I have pulled up here. And this is going to be the compound annual growth rate 1 workflow. And so what we have are the three values: the initial portfolio value, the final portfolio value, and the number of years. So now what we're trying to determine is that compound annual growth rate. So I'm going to go ahead and use a formula tool, which is under my favorites and also can be found under preparation. I'm going to go and drag and drop. And for the output field, I'm going to create a new field called compound annual growth rate. And for all those financial functions, they're available under this functions tab. And all of our functions are categorized. So really the ones we're focusing on today are going to be under finance. As you can see, all of our financial functions have a template for them. So if I just go ahead and double click on that template for the compound annual growth rate, I can actually start to see that formula here. And so all I need to do is really replace these values. And so what I'm going to do is replace these values with my data. So for the beginning value, I'm going to go ahead and use the field the initial portfolio, because this is the portfolio value at the start. The ending value is going to be the final portfolio, so the portfolio value at the end. And the number of years is going to just be the number of years field. So once I've filled in my arguments for my formula, I can go ahead and hit run. And now I can see that compound annual growth rate of around 25%. Okay, great. So that was just kind of a simple example to get us started. Let's get into a more complex example. So in this example, we don't have the data values all in one data set. So this is probably a more common example, right? In the previous example, we had the initial and final portfolio values all in one data set that's all nice and clean. In this example, what we have is our stock start values. So this is the closing value at this start time frame. Then we have the closing values at the end time frame. So these are in two different data sets. And then we also have some S&P 500 information. So associated to each stock is the security and some additional information. It looks like we have some sector information, some dates. And so the idea is I want to start to calculate the compound annual growth rate for each stock. And then once I'm able to do that, I really want to get at a high level what that compound annual growth rate is for each sector. So we want to start doing some aggregation on this data set. So in order to do that, let's think of a way of how we can combine these three data sets. So I'm going to go ahead and go into my join. And under our join category, there's really two join tools. There's this join tool, which allows you to combine two data streams. But in this case, we have three data streams. So let's go with the join multiple, which allows you to join multiple inputs. And so the way it works is I'm just going to drag it on here. I'm going to feed in the three data sets that I'm trying to join. And then all I need to do is tell Alteryx how do I want to join these three data sets. So luckily, I have this stock name that I can use, so this ticker value. So I'm going to go ahead and tell Alteryx I want to join based on that value. I only want to output records that join from all input. And then also do the nature of my data set. I can see they're all, the fields are all kind of named similarly. So let me go ahead and just rename them just for some clarity. So I can see the different inputs. So input 1 is actually the stock end. As you can see here, it's this number 1 connection. So I'm going to go ahead and put this as stock end. Input 2 is stock start. So let me go ahead and just change that for clarity. So once I've done configuring my join multiple tool, I can go ahead and hit run. And so now the result is the stock end, stock start values are on one data set, along with the additional S&P 500 information. So the sector, those dates, and addresses are now all in one data set. So now that I have it all in one data set, this is where I can do some further cleanup of my data. A lot of times what I'll do is just drop a select tool and start to change field types to make sure they're the most optimal. We actually have a great tool called the Auto Field tool. And what this does is actually automatically sets the field type for all of your string fields to the smallest possible size. So it really just kind of does that optimization for you. So we can go ahead and do that here. And again, this is just going to really change the field type. It's not going to change any of our values. So all of our data is going to look really, really similar here. So now that I've done some optimization of how the data is stored, I can start to use that formula I used earlier for the compound annual growth rate. Let me go ahead and drop a formula tool and calculate that compound annual growth rate. I'm going to go to Functions, Finance, double-click my template, and then the variables are going to be, so the beginning value, I'm going to go ahead and feed in my stock start. So this is the beginning value of the stocks. The ending value is going to be the stock end, and we're talking a time frame of 6 years. So in this case, it's not in my data set, but since it's a set 6 years for every stock, I can go ahead and type in 6. Once I do, I can hit OK, and now I can see that new field, compound annual growth rate for each of the stocks. So great, now I have it at this very granular level for each of the stocks. But again, what I was really interested in was at the sector level. What does that average compound annual growth rate look like? So I can start to summarize this. I can drop in a summarize tool. This is where I can group by that sector. So this is going to return a row value for each unique value of sector. And this is where I can choose any of my metrics and start to summarize them. So in this case, I'm interested in that compound annual growth rate that I just calculated in the formula tool. So I can click on that, and then I can go ahead and I can do a number of things to it, but in this case, we're actually interested in the average. So let me go ahead and go under numeric and click on average. So this is going to give me for every sector the average compound annual growth rate, and I can go ahead and hit run and see what that looks like. So now I get an output of kind of like a summary of the sectors and their average compound annual growth rate. But let's say I just wanted an easy view and I wanted to sort by the averages. So I can go ahead and go under preparation, and we have a sort tool. And this is where I can choose the average compound annual growth rate, and then I can go ahead and hit descending if I wanted the highest values at the top. And now I can see that the consumer staples is growing at a much larger rate than energy, which is one of the lowest. Okay, so that was our 2 examples for compound annual growth rate. So I'm going to go ahead and go back into the PowerPoint to review the other formulas that we'll be reviewing. So for the next formula, we're going to review present value. So especially when making a decision now, you really want to evaluate the value of your money now. So this can really help you determine whether or not you want to place your money in a project, or would you rather, instead of investing that money in a project, put it in an account that will gain interest instead. And so some of the drawbacks with this present value formula is it is highly sensitive, so it's highly sensitive to the time frame and the interest rate and it's inflexible. So the idea is you know some values about the future, you're assuming a set interest rate. So it's not really flexible in that case, and we all know that sometimes those interest rates can fluctuate in the future year over year. But let's go ahead and go over a use case for present value. Let's say we're trying to determine, based on two investment plans, which one offers a better deal. So one investment plan will return $12,000 in a payment in exactly 12 months. Another investment plan will allow us to receive $1,000 each month for the next 12 months. So we know some values about the future. We're trying to determine, well, today, how much is each investment plan worth? And then once we get those values, we can determine which one is the better deal. So let's go over the first one. So the first one is just a $12,000 payment in exactly 1 year at a yearly interest rate of 7%. So let's go ahead and we're going to use that formula tool again. We're going to calculate the present value. We're going to go under functions, again under finance, and we're going to look for that finance present value formula. In this case, we have 3 arguments that we're going to use. So the rate is going to be that interest rate, that 7% we mentioned. The number of payments, we're actually just going to get one investment, so that's just going to be the years, which is just 1. The payment amount, so we're not actually paying out, we're getting an investment. So it's actually going to be the negative of this payment, which is the $12,000. Everything else will be zeroed in this case. We'll go ahead and hit run. So now we can see that getting an investment of $12,000 in exactly 12 months at an interest rate of 7% is actually worth $11,214 today. So now that we have that, let's go ahead and calculate the present value for option B. So this one's a little bit trickier because we don't have our data set already formatted. So the idea is we're trying to receive $1,000 each month for the next 12 months. So what I want to do is actually get my data in a format where I have a row for each month. So what I'm going to do is a generate rows tool. And what this does is essentially it just creates new rules based on a logic that I will set up. So I'm going to create a new field called row count. The initialized expression is 1, so I want the row to start at 1, and I want it to keep going until it hits 12. And the way it's going to increment is just going to add 1 for every row it generates. So it'll basically just go from 1 to 2 to eventually 12. And then if you want to visualize that, just go ahead and hit run workflow. And now I can see that I have 1 row generated for 1 through 12. So I'm going to use this as my month. So this is great. I'm starting to kind of reformat this data in a monthly snapshot. The only thing is I have this interest rate at a yearly interest rate. So let me go ahead and calculate that as a monthly interest rate using a formula tool. And I'll call this monthly rate. So I'm going to use this interest and just simply divide it by 12. And then if I hit run, I can now see that monthly interest rate here. Now I have the month, and I have a payment of $1,000, which I can go ahead and just use in the formula tool. So now I'm going to go ahead and calculate that present value. I can go ahead and do it in the same formula tool if I needed to, or I can drop in a new one, which I'll go ahead and do in this case just for clarity. So I'm calculating the present value. I'm going to go back to that present value formula and double click. So the rate is going to be that monthly rate because, again, we're going to receive $1,000 each month for the next 12 months. So we're going to get that monthly rate. The number of payments is going to be the number of months. So it's going to be that row count that I generated. The payment amount is going to be $1,000, but again, it's a negative $1,000 because we're receiving an investment of $1,000. I'll go ahead and hit 0 for the other arguments. And then if I go ahead and hit run, I can start to see the present value of receiving $1,000 each month for the next 12 months. And that present value is $11,557. So in comparison between option A and option B, we can see that the present value of option B is actually a couple $100 higher than option A. So we probably want to go with option B. Okay, great. So now that we've gone over present value, our next term is actually future value, and it's really similar to the present value, except now we know the present value and the interest rate and the number of compounding periods. So now we're calculating the future value based on those values. So we're going to go ahead and go back into Alteryx. So again, we know the initial deposit, the interest rate, and the number of compounding periods. So I'm going to go ahead and drop in a formula tool. We're calculating future value. We're going to go into functions, finance, and then future value here. So the rate is going to be the interest rate. The number of payments is going to be the number of years. Payment amount will be 0. Present value, again, it's deposit, so we're going to go ahead and put in a negative right in front. And then we'll go ahead and do the same for this. So now that I've filled in my arguments, I can go ahead and hit run. So now I can see if I had $100 today at an 8% interest rate and I kept it there for 4 years, I would have a future value of $136.05. Okay, so that concludes our example for future value. And so now we're going to go into net present value. So this is really similar to present value, except it also factors in some costs. And so at the end of the day, the net present value estimates the worth of an investment in the long run over putting that money in like in a savings account to gain that interest. And so once you've calculated the net present value, a positive value indicates that you'll actually have a gain from the project, and a negative value shows that you're going to net a loss. And so you can kind of see the formula here. I think the best way to really visualize this is through our use case. So let me go ahead and go back into Alteryx Designer. And so for today's use case, we're going to think about making an investment. And in this case, we're thinking about buying a widget. And this widget comes at a cost of $100. And we know that this widget is only going to last 3 years. So we're not going to gain anything after 3 years from this widget. So based on a 4% interest rate, do I really want to invest in this widget, or do I just want to put that $100 in an account and have it gain 4%? And so the idea is when we're trying to make this decision, we're going to look at the net present value and see if we do net a gain from investing in that widget. So in my data set, I actually have data for 3 years and the cash flow for the 3 years. So as you can see, at the start, I have a flow of negative 100, because that's how much it costs to buy the widget, so I'm losing $100. And the next 3 years, I'm getting a positive cash flow from the widget. So I want to decide based on, the cost of the widget, based on the cash flow, is this a smart buy, or should I just have invested in and put it in an account? So we're going to use a formula tool, but first what I need to do is I can see that all my cash flows are in separate rows. And really, I want them in the same row if I'm going to use it in a formula tool. So let me go ahead and go to my transform. So under transform, we have a tool called a crosstab. And what that crosstab does is really pivots your data from rows into columns. So if I'm thinking about my data set here, I have my cash flows into rows, and I want them in columns so I can use them in my formula tool. So let me go ahead and drop in a crosstab. So what I want in my column headers are the year, and I want the values under to be the cash flow. So this is going to move the years from rows into columns, and then the cash flow from rows into rows also into the column values. If I go ahead and hit run, you can see now the years are up top and the cash flows are right below. So now that I have it in this format, I can go ahead and drop it into that formula tool. I'm going to go ahead and go to preparation, formula, and we're calculating the net present value. So I'm going to go ahead and go into finance, look for that net present value formula. And so the rate is 4%. So let me go ahead and add it in here. The values are going to be the cash flow, right? So we want to factor in the initial cost of the widget and then also the positive cash flows after. I'm just going to separate it by commas for each argument. So this is the initial cost of the widget of $100, and these are the 3 positive cash flows we had after we had the widget. If I go ahead and hit run, I can now see that I have a positive net present value, which means that I would actually gain from investing in this widget rather than just putting it in an account and having it earn 4% interest rate. So hopefully you can see how these types of financial formulas can help you make these types of decisions. Okay, so now we're going to go into our last term for today, which is the internal rate of return, the IRR. And so this is going to be the rate that makes the net present value 0. And the way it's calculated is we continually kind of feed these values into the NPV until we get a return of 0. And so the idea with this is you want this rate of return to be more than what your project or investment is going to cost. So for instance, what we have down here is if a project costs 5%, we definitely want the rate of return to at least exceed that. There are some assumptions behind this internal rate of return. It assumes that the investment is going to be held until it matures, that all the cash flows you're going to get are going to be periodic, and that any intermediate cash flows that you're getting from your investment are going to be reinvested at that same rate. So this is the one we're going to go over IRR today, where the NPV is 0, but there are some variations of this. So we have an XIRR, where the periodicity between cash flows isn't equal, and as you can see, we have some 2 other variations of this, which is also available in Alteryx. So let me go ahead and go back into Alteryx Designer. And so what we have here is a number of different departments with projects assigned to each department. And with each project is associated a cost, right? So either some hardware costs or maybe some staff costs. And so with each cost of a project, we have the benefits. And so we're trying to figure out, based on the cost and based on the benefits, are we seeing a high internal rate of return or a low internal rate of return? And in combination with the net present value, we'll be able to kind of make a decision of which projects are doing really well and which ones maybe we should cut off. So I'm going to go ahead and drop in a formula tool. And I'm actually going to calculate first that net present value, because that's also really important with the IRR. So we're going to go into the finance function, the net present value. And we're going to have to assume a rate because we don't have a rate built in. So the idea is, you'll have a rate in mind. So maybe I'll just say a 5% rate. And then I'm going to just put in kind of that cash flow again. So the staff cost, that's going to be a negative cash flow, right? So that's what the project costs at first. And then everything else will be a positive cash flow because these are the benefits. And again, we're just going to separate them by the comma. So this is very similar to the setup of our widget example, right? We're just trying to get the net present value. So now we can see based on the initial cost and the benefits what that net present value is, whether or not it's a negative or positive profit gain based on that 5% interest rate. Okay, so now that we have that, I can calculate the IRR. I'm going to drop in a new formula tool, but again, you can go ahead and calculate this in the same formula tool if you wish. And so this is a rate calculation itself, so it does not have an interest rate to put in. So I'm going to go ahead and double-click the template for Finance IRR, and the values are going to be the cash flows. So this is the initial cost of the project, and these are the positive cash flows after 5 years. And so now we're trying to see, is that rate of return high or low for each of the projects? So this is really good for comparing the projects against each other. So now I can see in one view which ones are gaining, have a positive or negative net present value, and which ones have a high or low rate of return. This is a good way of seeing it in the data set, but let's say we wanted to visualize this on a graph. This is where you can output to a format that you'd like. You can output to Excel, you can output to a CSV. We can also output to visualization tools like Click and Tableau, which I'm going to go ahead and do in this case. So the way you can do this is via an output data tool. I'm going to go ahead and drop it in here. I'm going to browse to my desktop. And I'm going to create a Tableau data extract, but again, these are all the different formats that we support outputting to, along with databases and some of the connectors that we have. So I'm going to just go ahead and put this as project eval. So I'm trying to evaluate which projects have a positive net present value and a high rate of return. Those are probably the most successful projects, while those with a negative net present value and a low rate of return probably are the projects that aren't doing well and maybe that I want to shelve. I'm going to go ahead and hit run. So this is going to go ahead and create that Tableau data extract for me. And again, this is just for a visualization of the data. I can go ahead actually, as soon as I create the Tableau data extract, there's going to be a link to where I created that extract. And I think it should be opening up. Give it a second here. So now I have the data extract, the TDE. So this is where I can start to create visualizations. So if I want to look at the NPV here as columns, the IRR here as rows, and then I'm going to separate it by the project code name as a label. I can see kind of a quick glance at which projects have a high rate of return and a positive net present value. So it's really looking at this quadrant here. And then I can see which projects have a negative net present value and a lower IRR. So this project alpha, probably, not a beneficial project. All the projects in the other quadrants, maybe there should be some further evaluation of what is that success criteria. Is it just about profits, or is there another benefit to those? So this is just kind of a good example of once you get your data into a format you'd like, once you have those metrics calculated, you can use a visualization like Tableau to really gain kind of a summarized graph of which projects are doing the best. Okay, great. So now I'm going to go ahead and go back into the PowerPoint. And then the next graph just really visualizes that too. So again, we're calculating these metrics to make decisions. And we want our decisions to be backed by numbers. So when we're calculating this net present value and the rate of return, that means something. And so with that high rate of return and that positive net present value, we probably want to approve the project. Anything that isn't going to gain any profit and has a low rate of return probably should be rejected. Anything in between, it's going to be up to your discretion on what other factors you want to review. So that really concludes the financial functions for today. Hopefully that was helpful, and hopefully you're able to see, you know, how Alteryx can get your data formatted in a way where it's easy to calculate those metrics. Once those metrics are calculated, you can start to summarize it or start to visualize it in a tool like Tableau. So now that we've concluded that, let me go ahead and go into some support options available to you. So again, we have our Alteryx community, so community.alteryx.com. This is where you can see what other users are doing. Maybe they're doing some other financial use cases that you would find interesting. Or maybe you want to post and share what you're doing financially on the community and share with others. We also have training resources available on alteryx.com/product training. So this is where you can, you know, watch other on-demand videos on other subjects or sign up for future trainings. And we also have our technical support team. So support@alteryx.com, along with a live chat and a phone number for you to reach. So if you do run into any issues and you don't want to post on community, you always have our email, our live chat, and our phone option to get those questions answered. And just want to remind you, please let us know how we did. So you'll be directed to a survey after you complete this webinar and we end the meeting. So please let us know. Hopefully this content was helpful, and we really want your feedback for us to make, you know, the content better. So thank you.